Music has three basic elements: rhythm, melody, and harmony. What we're going to look at now are the building blocks of these three elements. Melody. Melody is made up of a series of notes. But before we can explore notes, we need to talk about what makes a note. The first property that a note has is a sound that has a regular frequency to it. It's a sound, if you think about how sound waves travel through the air, it's a vibration of that sound that pushes the air to a person's ear so they can hear the sound. When that sound has a regular frequency, or it frequently vibrates at the same rate, then it has a sound that we perceive to be a note. So if I have a string, like on a guitar, and I pluck the string, you hear what you would perceive to be a note, okay? A sound could be any kind of noise, right? You clap your hand, it's one single instance, but a note has a property that you can recognize as something that might be singable, something that might be pleasant to the ear. Okay, so this is the idea of that sound in a note. And what happens now is this particular note sounds different than if I press right in the middle of this string and hold it down to shorten the size of that same string. I do hear that it's different. You might perceive it to be higher than, okay? So now what we're talking about is pitch, all right? So let's go back. Melody is made up of notes, and notes contain the property of pitch. Now I have another example for you using an oscilloscope. So now I have a synthesizer set up to an oscilloscope, and what the oscilloscope does is it measures the x-axis and the y-axis of the frequency, okay? So I'm going to play an A, the note A, and we'll talk later about how in music and in history people began to assign letter names to notate these pitches, okay? So this is the note A. I'm going to go ahead and play it here. All right. And it's just a single note held out, and the oscilloscope is recording the pitch. Now I'm going to go to the note A an octave higher. Okay. Now comparing that to the first note A, you'll see that the waves, the sine waves that go across the oscilloscope are different. In fact, if it is two notes that you're comparing that have the same letter name, what those two notes are, they are the low and high end of an octave, okay? Which means that those frequencies, the higher note is exactly twice the number of frequent vibrations as its lower note, okay? So this is the concept of an octave. If I go up to the next A up, then you'll see that those notes are moving at exactly twice the rate of the A before.